So you can proceed. Okay, so it has been done. All right, but with snpeff, one of the challenges, so let me just say one of the errors that you may encounter is with this message here, error underscore chromosome underscore not found. Okay, so this happens a lot, and it has got to do with the names of the sequence in the database itself, and then the names of the sequence. So in this case, chromosome. So let me just go over again. So one of the common issue that happens when you are running snpeff is this one here, error chromosome not found. Okay, so this has got to do with the names of the chromosomes in the database and then in your VCF file. So if there are inconsistencies, then you have this message coming up. Okay, so we are going to resolve it. All right, so don't worry about it. But I just thought I will let us do this first test and then get this error message, and you can use that to resolve. So hopefully, if you get an error like that, then you'll be able to resolve it. So before we resolve, let's just clear the screen. Let's do an ls, and then you are likely to see that no file will be generated or no output will be generated. That's fine. Okay, we had some errors. So we are going to resolve the error that we got. That is the error chromosome not found. So yeah, so to do that, let's look at the database which is here. So let's ls into snpeff /data/ specify the name. All right, so we have that information. So what we need to do is to check the name of the chromosome. Okay, that's the sequence, the name that has been given in this database, and compare with what we have in our VCF file, and we'll be able to provide a solution to it. So that's what we are going to do next. All right, so what we are going to do is to examine these files, this and then this, to look at the name that was given to the chromosome. Okay, now what you should notice is that with MS trans AG199, this strain has a plasmid and it also has a chromosome. All right, so we need to look at all those stuffs. Okay, so I will start with this one here. So there's sequence.bin. So I'll need to display the content. All right, so to do that, I'll say zcat, and then I'll say snip eff /data/ this /sequence.bin. So let's execute this command. So this will give us some information. All right, so with the information, just look at the last few lines here, and then look at this one, for example. All right, so we have the information here. We also have this accession ID, this one here, and we also have this. All right, and we have this and this. Now this one is a plasmid for AG199, the AG199 strain, but with the data we have, it's for the chromosome. The variants were identified on the chromosome. All right, so we need to also look at the name that was assigned to the chromosome, and then we can proceed with the issue. We can proceed with resolving the issue. All right, so now we have the plasmid, which is this one here. So if we had plasmids in the VCF file, then we would have also factored that in. But because we don't have plasmids, we can ignore this one. So what we are going to do next is to check this one also, because this one says sequence of chromosomes. So that means definitely what we are looking for will be here. All right, so we need to still do the zcat, then specify the file, and this time we say sequence dot chromosome dot bin, like this. So let's execute this command. Perfect, so we have executed it. So here, when we come to the example line, like this one here, you can see sequence, we can see this value 1, we can see this, and when we come here, we see chromosome, and we see the location, okay, or the position or the regions. Let me put it that way. Okay, so here we have this name here, chromosome. But if you take a look at the reference sequence, let me just do this. I'll do this again. Let me just do a head first. I think that will be better. We have this Now let me just open another terminal, that will be better. So let's take a look at our reference sequence. All right, so ls into data, we have this. So let's go ahead, data slash AGY99.FAST-A. So with the reference sequence, this is the accession ID. This is the name of the chromosome. All right, so we have this. So this same name is what has been indicated in the VCF, the original VCF, which is here. Of course, we process it, but the same information will be in those ones. But let's just focus on the original one here first. So I will also list the chromosome name that has been indicated here for the variants. So I'll use BCF2. So I'll say BCF2's query-f. I bring a quote, I'll say percentage, I'll say chrom/n like this. And then I'll specify the VCF file. That's the data slash snips ag199.vcf.gc. Now, because we have lots of variants, I just want to display just one of them. So I'll just say head/n to, let me just say head, that's fine. Okay, so I have that here. So here we see the chromosome. So there's the accession ID. So this one matches what is in the reference sequence. All right. But when we come to the SNP-EFF database, we don't see that. We rather see the name chromosome, which is here. Okay, so it is this differences. Okay, the difference in the names is what caused that error to be displayed, the error chromosome not found to display, because here we have this name here. So SNP-EFF is expecting to see this name in the VCF file. All right, the VCF file which we use, that's ls, this one here. Okay, so SNP-EFF expects to see this one chromosome in this VCF file. Okay, it can't see it there. So this one obviously will have the same accession ID as here. Let me just do, I think that would be better so that we are all on the same page. So I'll just reissue that command again, but this time I'll just use the input, so that's, let me just do it here. I'll just use the inputs, that's normalize.vcf, and do a head. All right, so we have that here. Okay, so there's it. So because of the differences, here is chromosome, that's the text, the word chromosome here, it's CP000325. And so this is what we have to resolve. Okay, so this is why we had that issue. I'm just repeating again. And so to resolve it, what we can do is to rename the chromosomes in our VCF file here, our inputs. Okay, so we have to rename it so that it has the same name as what is in the SNP-EFF database. Okay, so we have to rename them. So we have to name the CP00325, rename it to chromosome by this. Okay, so that's what we're, so that's the key to solving that issue. So with BCF2, it allows you to also rename chromosomes. I've covered that in another tutorial in detail, but I'm going to do a short demonstration here to show how to rename chromosomes. Okay, so this is what we are going to, let's just clear the screen. Let's do an ls and then proceed. So we are going to rename the chromosome. So to rename, we need to create a text file that has the name, the old name, the name that we are going to remove, and we also need to specify the new name. All right, so in this case, let me just go over this. So in this case, this becomes the old name, and then this becomes our new name. So we will create a text file and then do that. Okay, so I'll just do a copy of this one here. And I'll say nano new name.txt. So I'm opening a text file. I prefer to use nano, but you can use VI or any text editor, that's fine. So nano new name.txt, and then in it I'll paste the old name, space, and then I'll come and paste the new name here. I'll copy and paste it here. All right, so now we have that done. So now we can edit and save the changes. Okay, So if we save the changes, we can do an ls to take a look at the text file. You can do a cut to display it. That is fine. Okay. And now we are going to call BCF tools and then let's do the renaming. That's what we are going to do next. So let's just proceed. Let's do an ls again and then proceed. So we are going to rename the chromosomes in this BCF file. So the information is available here. That's newname.txt. Let me just do a cut to see it again. So currently this is what we have in the BCF file. So we are going to change all the occurrences of this to this one here. So we will use BCF tools, and to do that we will say BCF tools. Now say annotate. Now says dash rename -chr s like this. So BCF tools annotate rename -chrs. That means we are renaming the chromosomes, and then we specify the text file which has the information, which is new name.txt. So that will be new name.txt, and then I will specify the output format. Okay, so I will say -o. In fact, I don't even need to do that, okay, because when we don't specify an output format, then the default format is BCF. If you want a separate, or if you want a different output format, then you can specify the -o. But for this tutorial, let's just keep it with the default format, which is BCF file. Okay, BCF format. So I will leave it as it is. But if you want to change it, then you can just say -oz. That will save it as a bcf.gz. But let's just remove that. Let's keep it very simple. So we have BCF tools annotate rename.chrs, and then we supply it with a text file which has the information, and then we specify the inputs as well as the outputs. All right. Now I will start with the output first. I'll say -o, and I'll say snips_AGY99 dot normalize dot renamed dot VCF. All right. So this is going to be the output file. Remember, we have normalize, and I've added this information, rename. So this tells us that it's normalized, but we have renamed something in it. I always try to add some information to my file so that anyone looking at it will have an idea of what the file is. Okay, now let's specify the input file, and that's going to be this one here. So I'll just do a copy and paste. I can just type. So I'll say snips normalize.vcf like this. Okay, so this becomes the final file. Right. Let me just reduce the font size a bit so that we can have them in the same line, or yeah, on the same line. Okay, so this becomes the final command to rename the chromosomes. All right, so that's what I thought I would let you know. So now we can execute this command. I'll revert back to the first side. Okay, so now let's execute this command to rename the chromosomes. Perfect, so we have done that. Okay, so the chromosomes have been renamed. Now before we confirm, let's do an ls to see the output file. That is this one here. And so what we are going to do is to now run BCF tools query to take a look at this file and then display the chromosome names. So I'll say BCF tools, and then I'll say query -f. I'll bring my quotes. I'll say percentage /n, and then I'll specify the file, which is snips normalize.renamed. I'll just say head. Now execute the command. Now you can see that what the chromosomes have been renamed to this one here. All right. Okay. Now, if let's say you don't see the word chromosome in that database, then you have to use the appropriate names. Okay, so the same format. So take note of that. All right. So now we have this one. So this one matches what is here. All right. So now we can rerun snpeff, and then we are sure to get what we want. Okay. So this is what I want to do. I'm now going to rerun snpeff again. and then get the command. Okay, running. So I repeat, I'm now going to rerun snpeff and then get my variant effects predicted for me. Okay, so I'll clear the screen. I'll just do an ls just to check my stuffs again, and then I'll recall that command. Okay, the one we use. So if you want to recall a command, just use the up arrow on your keyboard and then just press it until you get to the command. So you don't need to type everything again. So we are going to rerun, but this time we have to change the inputs because we now have this one here. This is what we are going to use. So I'll need to clear this one here and then supply it with this one here. So that's a snips normalize.renamed.vcf. So this becomes our new inputs. So this is what we are going to use now. So let's execute this command. Okay, perfect. So now it's been done. So now you can see that snpeff is working nicely. So far, you have not seen any error. Everything is being done. So you can see that the variant effects have been predicted for us. So you can see all of them here.